Hello everyone. Today we are facing a crisis that's happening faster than we can respond to. That is deforestation. Every passing minute, a massive stretch of forest disappears. And this isn't just the loss of trees, it's the loss of biodiversity, the worsening of climate change, and the collapse of ecosystems that sustain life on Earth. But the real challenge isn't only that it's happening, it's that we are discovering it far too late. The system we rely on today are slow, outdated, and reactive. By the time deforestation is detected, the damage is already done. Let's look at the before, the way things are done right now. First, it is incredibly slow. It typically takes 3 to 6 months for authorities to receive and confirm a report of illegal deforestation. By that time, the area is cleared, the wood is sold, and the criminals are long gone. The damage is irreversible. Second, it's expensive and manual. It requires huge teams of people to manually analyze satellite images. And maybe the biggest problem, environmental limitations. Most monitoring is optical. The moment you have clouds, fog, or just the rainy season, which is all tropical rainforest, you are completely blind. This is where GreenGuard AI changes the game. We are not talking about reports in months. We are talking about real time alerts within 24 hours. We are not talking about high costs. Our system is automated, which slashes operational overheads. And most importantly, we solve the blindness problem. We have all weather capabilities. But how? Our system AI core is built on a hybrid model using both CNNs and vision transformers. It processes data from Sentinel, Landsat, and crucial all-weather radar data. For us, a cloudy day doesn't matter. We are always watching. This engine feeds into a powerful prototype I am about to show you. Okay, let me show you exactly how a working prototype functions. What you are seeing here is our main India deforestation dashboard. Right at the top, we provide a high-level nationwide overview. The total forest area at 80 million hectares, the total tree cover loss since 2000, and the primary forest loss. But the real power is in this, our interactive deforestation map. Each of these dots represents a high-risk area, and they are color-coded by severity level, from low and moderate to high and critical. This isn't just a static map, it's a live, interactive tool. Let's zoom in here on the northeast region, which we know is a hotspot. I can click on any of these critical dots. Let's take this one in Manipur. Instantly, the dashboard gives us all the critical intelligence for the Manipur Valley. We see it's a high risk area. Why it is happening? Growing urban pressure and mining. And the hard number, 1,89,000 hectares of total loss. And look at this, 98 new alerts this month alone. This is what we mean by actionable, but we take it one step further. We don't just show past data, we use AI to predict the future. I can click right here on AI powered future predictions. The system immediately gives us a projected loss timeline. It shows a 76% risk level and projects that cumulative loss for 2025, 2027, and 2030. If current trends continue, it even identifies the primary drivers, agriculture expansion, and mining, and give the exact coordinates for authorities. This allows officials to allocate resources before the forest is gone. Let's look at another one. Here in the Nagaland forest belt, 128 alerts this month. We check the AI prediction and we see the projected loss and the drivers shifting cultivation and logging. The system works across the entire country. We can go down to the Odisha Eastern Ghats, 48 alerts, or over to the Chhattisgarh Sal forests, 36 alerts. In every case, authorities get a complete data-driven picture. Finally, scrolling down, we also provide historical context. You can see the tree cover loss by year in this bar chart and a top affected states list, which help identifying long-term problem area. This entire dashboard is designed to do one thing: turn complex satellite data into simple, actionable, and predictive insights so that we can get ahead of the problem. So you have just seen our dashboard in action. Now I want to briefly explain the core technology that makes this all possible. This is our technical approach. It all starts with data ingestion. We pull in data from multiple crucial satellite sources. This includes optical data from Sentinel-2 and Landsat. But most importantly, we also integrate ESA biomass radar data. This radar is the key to all our weather capabilities. It can see right through the clouds that blinds other systems. Of course, that data all comes in different formats. So pre-processing is essential. We use tools like the Google Earth Engine and OpenCV to clean, align, and harmonize all these different data layers. Our AI can understand them as a single picture. Next is the AI ML core. This is the brain of GreenGuard AI. It's a hybrid model that combines the strength of convolutional neural networks with advanced vision transformers. This hybrid approach, inspired by cutting-edge research like tree formers, is incredibly effective at detecting the specific patterns and textures of deforestation. Once the AI finds a high probability event, it triggers the alert system. This is what you saw in action. It sends those real-time notifications directly to the web dashboard and to a mobile app for officials on the ground. And all of this leads to the final, most important step: enforcement. Our system isn't just for making reports, it's for facilitating swift action by forest, giving them the exact coordinates and data they need to intervene. And I want to emphasize that this entire approach is built on strong, credible foundation of academic research. We are not just guessing. Our system is validated by a wealth of peer-reviewed science. For example, research like Silva et al. 2022 has already proven how near real-time detection pipelines like ours have a direct and measurable impact on enforcement efforts in the Brazilian Amazon. Similarly, papers like Henson et al. 2022 and Karaman et al. 2023 were fundamental. They demonstrated the power of using SAR, radar, data and attention-based transformer model to robustly detect deforestation, even in areas with heavy cloud cover or noisy data. By building on these proven, published concepts, we have created a system that we know is not only innovative but also grounded, credible, and effective. So to conclude, GreenGuard AI is an AI-powered system that analyzes satellite imagery to detect illegal deforestation and degradation in near real time. By combining advanced computer vision models with the cloud-based dashboard you saw today, it enables faster, more accurate forest monitoring than ever before. This solution is designed to be scalable, cost-efficient, and all-weather capable, directly addressing the core failure of traditional monitoring. Our mission with GreenGuard AI is to move beyond just reporting on the forest we have lost and to start actively protecting the forest we still have. Thank you very much for your time.